Okay, so as a reminder, what we've got is we've got a couple of stage tables, and note here that we've got our reference to our source tables as raw.jaffleshop customers, and the stage and orders raw.jaffleshop orders. And again, we've got some dimensions going on with our staging tables feeding directly into our dimensions. What we really want to do now is introduce the concept of sources into our DBT project. And what will then appear in our lineage diagrams right here is the source that feeds our staging customers and staging orders. What that means is if we change it again in the future, could be really time consuming to go through all of our different models, locate where the references to the source tables are, go through, refactor them. Using the sources module within DBT allows us to modularize that in a similar way to what we've seen in previous videos in a similar way. So let's take a look at that. So what we're going to do now to be able to configure this is we're going to add a file to our staging folder. And we're going to call this jaffleshop source underscore jaffleshop.yaml. And this is what's going to contain our configuration information for our sources within this project. So in the YAML file, I'm going to give it a version. I'm going to call it version 2. I'm then going to start specifying my sources. So I type sources. I hit return, I hit a double space, and then I'm going to type in name. And in this case, the name can actually act as an alias. If you don't specify an alias, DBT will just assume that you're working with the schema. So I'm going to specify the name as Jaffleshop and the database as raw. So although it's not necessary to do this, it is DBT's best practice to specify the name in the database, because if things change in the future, it's a lot easier to have self-documenting code to be able to find what you need to change again in the future, and especially if it's not yourself or that's changing it, it could be another team member or a colleague. It's much better to be explicit, and it doesn't take too long to do it either. And then we're going to add the schema. This Jaffleshop. I'll just correct that bit as well. And now right beneath here, we can list out our tables. So double space again, we can go name. So we had the customers table and we had the orders table. So if we go back to stage and orders, we can see here that we still don't have any sources because we haven't changed this hard coding to our source table yet, which we'll come back to in a second. If we go to dim customers, you can see that we're able to generate this lineage diagram because we use the reference function to our stage and orders in our stage and customers, effectively telling DBT where this data is coming from within the project to be able to populate our dim customers table. So what we really need to do now is we need to be able to replace our staging tables using the source function to be able to generate that lineage diagram. So we'll start to get sources populating on the left hand side of this lineage diagram here, which will be very useful for both technical and data consumers further down the line as well. Okay, so how do we do this? Well, it's a little bit similar to the reference function. So we start with the double curlies. Let's get rid of that. And then we type in source. Think of this in many respects like a SQL function where you will input certain values and expect a certain output. It works very much in a similar way. In this case, we need to give it a source. So the source is Jaffleshop like we described in our YAML file. The next input value it takes is our source table. In this case, it's orders. So we'll pop that in there. And so by clicking save on our YAML file in our stage and orders file, this is what now shows up. Because we're using the source function and we specify the name Jaffleshop and orders in our YAML file, it comes down, looks for the schema in here, it looks at Jaffleshop, it looks for our table in here, and it's able to then make that association within this model, stage and orders, and we get a nice neat lineage diagram from our source table right the way through to our target presentation layer dimension and facts in this case. And a really easy way of checking what's going on behind the scenes is clicking on compile SQL, click and compile, and you can see that it compiles exactly to what we had hard coded before, but now this is evaluated at runtime rather than hard coded up here within our model within DBT specifically. So this allows us again to leverage the modularity in DBT. We can go back into the YAML shop file, the YAML file at any point in the future and just change this one reference to things. And that will propagate through. Imagine now if we had, hundreds of staging tables, which would be quite typical. We don't need to go through all of those and refactor them. We can just change it in the one YAML file using this approach, and everything now will evaluate correctly, and our lineage diagrams will be up to date as well. So really neat feature and something that you should look to really use within your own projects as well. So let's do exactly the same in our staging customers table. Again, we'll take this, we'll get rid of it, we'll do our double curlies, and then we'll use our source function, Jaffle shop, and customers. Save that. We'll check our lineage diagram. And there we go, that's updated for our source table in there now as well. And we'll just compile the code and look at our compile SQL in a second when it's finished compiling the SQL. There we go. We can see that's going to work. No trouble at all. So the next concept I would like to introduce you to is something called source freshness within DBT. And this is where DBT can tell you if your source tables are out of date and the data has gone stale based upon a date time field that you tell it is representative of the data that you need within your presentation layer, for example. So in this case, we can create a new query window, for example, and we can get rid of this. So you just do that by clicking the plus sign at the top right here. And we can then just look at this by selecting from this actual source table. So again, we can use the source function directly within DBT. We don't need to switch back to Snowflake in this sense. We can just run the same queries. So Jaffle shop, and then the source table. In this case, we'll look at orders. Okay, so let's look at the table here to see what our last loaded date by the ETL is. And we've got a field here called ETL underscore loaded underscore at, and that was the last time our data was refreshed. And so one thing that's really handy is you can see about using DBT is that you don't need to flick between Snowflake and run a query. You can just do it all within DBT. It's really handy for a lot of users and makes things more efficient. Now we know the name of our column, we can go back to our YAML file here where we specified our source metadata earlier on. There's actually a parameter, if you like, called loaded at field. And this is what the source freshness is based upon within DBT. It's based upon this field. So the field that we're using, like we just saw, is obviously for the orders table, we've got specified here, is ETL loaded at, and then we give it the freshness parameters we want it to operate within. So we can say when we would like DBT to warn us after a certain period of time that our data hasn't been refreshed, and when we wanted to actually generate a hard error and have us look into it as well. So we use this freshness option here, and we can then say warn after, and in this case we're going to say 12 hours. So we're saying a count of 12 increments, the period being 1 hour. So 12 of those periods effectively, it's going to warn us if the data is gone beyond 12 hours before that field basically says it's been loaded again. And we're going to error after. In this case, we're going to say 24 hours, a period as error again. So you can see there's different scales. We can get a warning after 12 hours that the data is out of date and has gone stale. 24 hours. Obviously, it's going to be different within your environment, but again, really quite nice to be able to modularize it all within the same YAML file and detail your sources out in this way. Specify your fields. Again, some tables may be more critical than others, and you may want to have a narrower window on those. In this case, we're just going for 12 and 24 just for demonstration purposes. So before we run anything else, let's just go back to our Scratchpad here. We can see everything here was loaded on the 29th of March. Today we're in May. Okay, so it's way beyond the kind of freshness parameters that we just told DBT about. So what we're going to do, we're going to save our YAML file. Really important that we remember to, as we go through and making changes, we save things before we run it. And then we're going to run dbt source freshness. We're going to run that command. That's going to go off then, look at our YAML file and work out what the freshness of our data is. And you can see we've got a failure on orders, which is no surprise. That's exactly what we expected to see. And it's telling us that the data is stale now because the last time that date timestamp was updated was in March. We're now in May. And we've told it to generate an error for that table only. And that's how it works. And obviously it can notify you via different means on Slack, for example. And if that's of interest to you, let me know in the comments below. We'll gradually work through each section of DBT and each bit of capability that it has, so I can just explain it in a staged basis as well. So that's really useful. Obviously, if you need to, let's say you don't have access to the ETL tools, let's say you're a data analyst or data scientist outside of your IT or data teams that provision the data for you, this is going to be really useful to get a sense of, well, has the ETL populated that data the previous day? Is it out of date? Is it worthwhile me running these ML models I've got, for example, or this particular report or analysis today? If you don't necessarily have access to the ETL tools or the monitoring or visibility of the monitoring around that, this can be really useful in that sense, where you can just go into DBT, you can actually query the actual housekeeping columns on those tables to see when the data was last loaded, and you can find out instantly without having to raise a ticket, pick up the phone to anybody, or send an email into the help desk. So again, really kind of looking to democratize the use of data across your organization. May not necessarily be apparent when you look at it from this perspective, but it's one of many features that helps reduce that bottleneck and improve efficiency across your business as well.